Login accepted.
Hello everyone, welcome to Cal Poly Pomona's Cybersecurity Awareness Fair. I have a question for you. Is multi-factor authentication enough? Many people may believe that multi-factor authentication, or MFA, is enough to stop attackers from hacking into your accounts. While MFA does make it more difficult for attackers, what if I said that there are ways that attackers can get past this barrier? There are a variety of techniques that attackers can use to bypass MFA and be able to access your accounts even if you have MFA enabled. And I will be doing a demonstration on one of those techniques using a tool called EvilGenX. Just to introduce myself, my name is Taylor and I am currently a 4th year student at Cal Poly Pomona. I've participated in various competitions such as CCDC and CPTC and also serve as the president for Cal Poly Swift, or Students with an Interest in the Future of Technology, which is a student organization that focuses on various aspects of cybersecurity with a hands-on approach. If you want to learn more about what we do, you can visit us at www.calpolyswift.org. First, we'll talk briefly about a man-in-the-middle attack, or MITM for short. Then we'll discuss a little bit about MFA. Next, we'll go into a demonstration of EvilGenX, which is one of the tools used to bypass MFA. And lastly, we'll talk about how you can protect yourself against these types of attacks. And just a quick disclaimer about the demo. This is only for educational purposes, and unless you have explicit consent to do so, please do not perform these types of attacks. You have been warned. First, what exactly is man-in-the-middle? Man-in-the-middle is a type of attack where an attacker places themselves in between a user and an application, such as a website. This allows them to eavesdrop on the communication and steal personal information such as usernames, passwords, credit card numbers, and more. For example, if this user wants to log into a website, they would have to supply a username and password. Normally, this username and password would be sent to the website, and whatever information the website wants to respond with will be sent back to the user. However, when man-in-the-middle is involved, the username and password would be sent to the attacker instead, which then goes to the website. And then whatever information the website wants to respond with, that information is going to go to the attacker, which then goes back to the user. And that is the basis of man-in-the-middle. Next, let's talk about MFA. When you log into online accounts, normally you would provide a username and password. The problem with this is that usernames and passwords are often easy to obtain, which would make it extremely simple for attackers to get into your accounts. This is why so many online services are adding another layer of security by requiring an additional step of verification beyond your username and password. This usually comes in the form of tapping yes on your phone when you get an email that contains a code that you have to put on the website, so on and so forth. The goal of MFA is to make it more difficult for attackers to compromise your accounts, but once again, this is not going to stop them completely, as there are ways to bypass these controls. To explain what I mean, let's quickly talk about cookies. Cookies are used by websites to remember who you are. When you provide things like your username, your password, any MFA verification methods, the website will create a cookie for you and give you that cookie that is unique to yourself only. Later on, when you want to access the website again, you don't need to enter your credentials again. Your browser will automatically send the cookie to the web server, which is used to authenticate yourself. In other words, the website will remember you through the cookie that you provide. And this happens all the time when we browse the internet. When you sign into sites like Amazon or Google, chances are you probably don't need to log in every single time you visit those sites. Sites will just magically remember who you are, but in the background, it's mainly just how cookies work. Now, let's see what happens in a situation where there is a man-in-the-middle attack going on. The user will send over their username, password, and any MFA verification to the website, but the credentials aren't really going to the website. They're actually going to the attacker, and the attacker will intercept this information, then send it to the website. Assuming that these credentials are valid, the website will send a cookie back to the user, but once again, this cookie is not going to the user directly. First, it's going to be intercepted by the attacker, who will then relay this cookie back to the user. In the end, the attacker will have valid credentials and a valid cookie that they can use to their advantage. From the user's point of view, however, everything will look completely normal because at the end of the day, the communication still goes through from sender to receiver and back. And this is what makes the attack very dangerous and very stealthy. If we recall from a while ago, MFA requires an additional step to verify a login, which means just having a username and password is not enough to access an account when MFA is enabled. However, in the second part, the attacker has also collected a valid cookie, and this is the critical part of the attack. With the valid cookie of the victim, the attacker can then access the website as if they were the victim, which basically means the website will grant the attacker access into the victim's account without needing to provide any username, any password, or even any MFA verification step. Obviously, this is not to say that the credentials are useless. The credentials are still very useful for an attacker because attackers can use those credentials for any different sites or accounts and see if those credentials work, or perform another MFA related attack called MFA prompt bombing, which is basically when attackers spam the authentication request or MFA request to a user in hopes that the user will get tired or annoyed of the MFA request and just hit accept. But this whole cookie interception thing, this is exactly what the tool EvilGenX does. Perform a man-in-the-middle attack to obtain a valid cookie from a victim. This cookie can then be used by an attacker to access the victim's account without providing any username, any password, or MFA verification steps. So now let's jump into the demo. So in this demo, we are going to use EvilGenX to access a GitHub account with MFA enabled. For context, we will be performing this MFA attack against an individual who goes by the name of Steve Canato, the CEO of a company called Candleworld. Here is the website for Candleworld if you want more information. And by the way, this is all fake. This is all fictitious. The accounts we'll be attacking don't belong to any real human. None of the employees are real. And by the way, these faces are AI generated, so that is pretty cool. But once again, everything in here is going to be fictitious, non-real characters. And none of these are attributable to any real human being. So before going through the EvilGenX things, I just want to show you that part of this attack required me to set up a valid domain, and my valid domain would be candle.info, as you can see here. There are also some DNS records that I have created, but I'm not going to go too much into detail about those. I just want to demonstrate this attack and see how it works from both the attackers and victims' perspectives. So here, I am on a Cal machine, and first thing I'll do is to SSH into my EvilGenX server, which is hosted on AWS. If you want to host this yourself, then you will have to set up your own AWS server, which I'm not going to be covering about, but this is what I will be using. So I'm going to SSH into here, and next I will run sudo EvilGenX to start up my EvilGenX tool. We should see some artwork on the title of the tool, the creator, and some other log information stuff, but those are not too important right now. But what we do see down here are fishlets, or fake login pages that we can use to mimic a real login site. There are fishlets for sites like Reddit, Facebook, GitHub, and a bunch of others, and these are all created by folks that have contributed to this project. You can see the authors over here. and all of them are disabled and available. Because we're targeting a GitHub account, we would want to focus on the GitHub fishlet. But before we create any fishlets, we first need to configure the IP address and domain name that our tool EvoGenex will use to carry out this attack. So what I'm going to do is type in config IP and then my public IP address that corresponds to this public box is 44.233.227.9. And next I will configure my domain, which is config domain candle.info. And now my IP address and domain are set for EvoGenex to use. Now we can create the GitHub fishlet. We can run fishlets hostname GitHub and then github.candle.info. Basically what this command is doing is it's going to configure a GitHub fishlet with this fishlets hosting GitHub, and then it's going to use this domain name and is going to correspond this domain name with the login page of a GitHub login. And you'll see how this works in a little bit, but first I just need to set this up. So I'm going to run that command, and then I'm going to run fishlets enable GitHub to enable this fishlet. And now it's going to request SSL or TLS certificates from Let's Encrypt, and this is going to make it so that once we go onto the site, we don't run into any of those like insecure errors or warnings that browsers usually give us. So this is going to help make our attack look a lot more legitimate. So now that we have created the GitHub fishlet, or enabled the GitHub fishlet, now we can actually get the URL where this GitHub login page will correspond with. So that is what leers are for. When what we're going to do is type in leers create GitHub. And this is going to generate a leer, which is going to be the URL for our GitHub login page. I'm going to type in leers edit and then the ID of our leer, which is 0. So I'm going to type in 0 over here. Redirect underscore URL, and then I'll just type in the GitHub sites. So what this is going to do is after the victim has logged in and provided their MFA code, EvoGenex will redirect them to this GitHub site. Now, if you want to get the URL of this leer, you can just type in leers get-URL 0. And it's going to show me, a website, github.candle.info, with this random string of characters at the end. And typically, if you're like on a red team engagement or something, you will want to edit this a little bit more. There are some commands that allow you to change the directory of the login page. So you can change this to be like login or admin or something like that. But for now, we won't cover that. We just want to generate a login link and see what happens on the victim's side. So now let's say that we are Steve Canato and we received this link in a phishing email or something. We won't talk about phishing emails, but our friends from MISA will have an entire talk on phishing and machine learning. So if you're interested, please check them out as well. So anyways, this is what Steve Canato will see. So let's pretend that I am Steve Canato now, and I'm going to paste in my URL. And this is basically what we see. It is a one-to-one replica of the actual GitHub login link. And this is pretty scary because it really does look the same thing as the valid GitHub login page. So let's say we are Steve Canato and we want to log in into here. So I'm going to type in Steve Canato's username, which is stevecanato321@gmail.com. And once again, I am pretending that I am Steve Canato. An attacker would not be able to use his login, but only Steve Canato would. So I'm going to type in Steve Canato's password. that password is valid, but now I am asked for an authentication code, which I have with me right now. Should be that. And it looks like I get redirected to regular GitHub sites. And this would probably not raise any alerts from Steve Canato's side. But if we go down, we can see on the attacker side that the username, password are captured, and a message saying all authorization tokens intercepted. And what EvilGenex is saying here is that we have successfully captured the cookies of the session. So if we remember back to our discussion earlier about session cookies, this is a valid session cookie that we have taken from Steve Canato. And as an attacker, if we were able to take this cookie or token and put it into our own browser, then theoretically, we can access Steve Canato's account without having to supply any username and password. And that is exactly what we're going to do right now. So if you want to see what this authorization token is, we're going to type in sessions. And you can see that we have a session ID of 1 that uses the GitHub fishlet with the username Steve Canato and our password. Tokens were captured and some other details over here. So if you type in sessions 1, then we can actually see the full cookie of Steve Canato's session. And this is all in JSON format, but we can take this and put it into our browser to hopefully be able to access Steve Canato's GitHub account. So first thing I would need to do is make sure that I have a cookie editor extension, and I'm using Firefox for this. There might be other ones for other browsers, but for Firefox, it's called Cookie Editor. And we have some options where we can like add cookies, import cookies, export cookies, but we're going to focus on this import cookie option. I'm going to make a private browsing session for now, and first I'm going to go to GitHub. Then I'm going to copy this, and going back to my private window, I'm going to import the cookie. I'm just going to paste it. It's going to be kind of long, but if I paste it in and I import it, and then I refresh, then it's going to give me some interesting information. Looks like it wants me to confirm some account recovery settings. I'm just going to click remind me later. It's going to give me some weird errors and stuff, but no need to worry. If we go back to the actual GitHub site, we can see that we are logged into Steve Canato's account. And Steve Canato has some interesting repositories. Here's a really cool one called Power RVB, which is created by some of the folks from Swift. And this is a really cool repository. But we were able to access Steve Canato's account without having to provide any usernames, any passwords, or any MFA codes or tokens. And that is the beauty of this attack, being able to bypass MFA through stealing a valid user's session cookie. Now I would want to show you how you can actually detect or mitigate against this kind of attack. There are a group of researchers that have created a tool called FOCA, which essentially scans a login page and looks at the responses from a login page to determine if the login page is malicious or not. So there's a tool called FOCA out there. So I'm going to browse into the FOCA directory over here on my machine. And there's a tool called FOCA, which is, I think, written in Python. So if I just type in Python 3 FOCA, you can see there's the help menu. And it's basically asking to provide a domain to classify as a man-in-the-middle phishing website. And you can also put in like a text file with a listing of domain names you want to check. But I'm just going to use our recently created github.canada.info site. So if we take a look at this, we try to run this, it's going to take a little bit of time. And after it's complete, it's going to say that this link is phishing. And that is pretty cool. And I think the reason why this happens, so we can look at the regular GitHub site. So we just type in like github.com. It's going to return non-phishing. So I think what's happening in between these two is that the responses from github.canada.info and the responses for github.com vary a little bit. There might be some different responses from github.canada.info that provide indicators that the link is a phishing link, while the regular site does not have those indicators. So it's going to return non-phishing. So this tool can be used to detect if a link is phishing or a non-phishing link. So just to recap on what we have performed in the demo, we have set up EvoGenX to place ourselves in the middle of a communication between a victim and a service. The victim being Steve Canetto and the service being github.com. Steve Canetto had provided his credentials and MFA code that we were able to intercept. And not only did we intercept the credentials, we were able to obtain a session cookie or token from the website back to the user. And once we imported that cookie into our browser, we were able to go on GitHub, import that cookie. And once we were able to obtain his cookie, we can go on to github.com, import his cookie, and send that to the website to pretend as if we were Steve Canetto. And what that is going to do is provide us access to Steve Canetto's GitHub account without having to provide any usernames, any passwords, or any multi-factor authentication steps, effectively allowing us to bypass multi-factor authentication. So thank you everyone for watching this demonstration. Feel free to check out the other booths or demonstrations if you haven't already, and I hope you have a great rest of your day. Thank you.